Thank you very much. All right, so I'll have to accept the recording. Hi, everyone. My name is Elena Sinelnikova. I am a CEO and co-founder of Metis.io. And today we're going to be talking about blockchain for DevOps. So let's get started. As I said, my name is Elena Sinelnikova. I actually came from the DevOps background as well. I worked for 25 years basically as a DevOps, and then I founded my first company, which was nonprofit organization, Cryptography, and also now I co-founded Metis, which is building on the blockchain. So therefore, I can deliver you all this knowledge. Disclaimer, so this is of course, because we will be talking about crypto and blockchain. Of course, we need to make this disclaimer, so we're not asking you to purchase anything. So this is just for your education, for your information. We also not promoting anyone with this presentation. This is all the tools and the resources that we used and that we trust. And that's what we're telling you about. So the first resource that we used and trust is Cryptography Academy. So everything that you learn today, you can find there as well, and much, much more. If you need to build your first blockchain app, for example, you can find the courses there. It's 1-hour courses. So pretty much we recommend you to do that. And today we're going to learn about blockchain, decentralization, cryptography. We're going to go through architecture of blockchain, what to build on blockchain, how to build it, what problems blockchain has, and how to solve them as well. And we have also the job opportunities that we want to highlight for you. So starting with a blockchain. So what blockchain? In essence, blockchain is a database. As DevOps, you know what database it is, so I don't even stop on that. Yes, it is a database, but normally how we know it, a database is, it's somewhere located on some company server, on a big mainframe or something like that. But as well, the Facebook, Google, everything, everywhere you turn right now, everywhere it's databases. But you know it by heart because you're DevOps. But blockchain is a decentralized database, and that's what is different. So it's not the data that is in this blockchain database is not located on one computer or like several computers that belongs to the company. It actually located on the people's computers at home, distributed all over the world. So these computers can be all over the world. And that's what we call decentralized. And all these nodes are owned by people, not the companies or the corporations. So the corporations don't own anything in there. It's all belong to people. And that's what decentralization is. So who owns them? Pretty much, kids, guys, grandmothers, anyone who can download how we call it blockchain core on your computer, and then voila, you have all the files in there. You can go inside, you can take a look. It's pretty open. The only thing you cannot change it files, how to change and how to make a record in this database. We're going to be talking a little bit further. Today, we're going to be talking about mostly two blockchain, two most popular ones, Bitcoin. We're starting with Bitcoin, and we're going to Ethereum as well. Bitcoin was first, so right now the architecture is actually Bitcoin-like. So what's inside this database? Inside this database that on people's computers at home, distributed all over the world, it's the transaction ledger. It's basically the list of transactions, people transferring money from one account to another. And these accounts are also in the blockchain. So they exist as the transaction ledger list. Right? So like everything that you, for example, you send money from one person to another, from you to your friend, and that sort of transaction get recorded in the transaction ledger. How these computers are connected. So these computers are connected, and you can guess, and if I would do in this presentation live, I would ask you, and some of you even give me the correct answer. Though I'm not really getting correct answers all the time, but yes, these computers are connected with internet. So they all connected with the World Wide Web, and this is as simple as that. So can you imagine all these computers are connected between each other with internet? They're located all over the world. So imagine how we can kind of destroy blockchain, right? So this is the task, how we can get rid of it. So let's say that I'm a president of a country and I would like my people not to use it anymore. So what do? Here I have on the slide a demonstration. I can actually go back and forth, maybe between the slides there. So here you see pretty much even like the president of a country, you know, something that prohibit people to use this. Doesn't happen really anything to database. It does not affect it because it's spread all over the world, and that's the power. And it doesn't belong to any single company, so you cannot go and sue somebody. So that's the thing, and this is the power, and that's why it is so right now popular, I guess, because it's not in the control of any governments, unless all the governments of all the worlds, of all the countries agrees between themselves, which we know never gonna happen. But we still can destroy it, you know, and that could be one of the scenarios. Of course, I'm joking, because even then, if one computer survives, we still have this database, we still have this ledger. Therefore, blockchain, decentralized blockchain is undestroyable as we know it. So just a little sum up from what we have so far. So database, it's a public ledger of information. It's decentralized, it's owned by no one, controlled by consensus of all the users and all the people that are in a network, and users, people who are installed blockchain program on their computer. So there you go. So basically, you can think of it as one gigantic infrastructure, which actually is supported by people. And how it is working, how people actually support it, and who wants to support it. So that we're going to go and look at it further. So first, we're getting into the term of cryptocurrency, and that's how people are getting paid by who's supporting this database, right? So in a cryptocurrency, it's a digital or virtual currency that's secured by cryptography, and that's what it is. And the cryptocurrency transaction ledger is stored on a blockchain. So yes, itself, a system produces its own cryptocurrency. It's paid for the service in this currency, and it's also stored transaction on the blockchain. So there you go. This is what cryptocurrency is. So how digital money become cryptocurrency? Same as all digital money. For example, so when you have, of course, money in cash, it's very easy to have them as a medium of exchange. Well, not probably the paper money, but you know, the gold, like the coins, the money. So this ones. But how is the digital money? I can send one digital dollar to one person and the same digital dollar to another one. But that's how exactly why we have a blockchain, which is the most secure right now technology, which never been hacked, and the records never been changed. So therefore, if your transaction of you sending $1 to someone else is get reported, the record of it, everyone can see it. And therefore, the double spending is not possible in there. And therefore, that's how the money, digital money becomes the money. That's how cryptocurrency becomes digital money, right? So, and also security is really, really tight in there. So we're going to be going through that as well. Usually when you deal with cryptocurrency, you start dealing with a wallet. So wallet is the program that you install and run on your computer. It's also kind of the node in the blockchain. And it creates an account for you. It can create an account for you, giving you a private key, right? And account number. So private key similar, like a password, account number similar to bank account. No one ever can have access to your private key. If you give away private key to someone, it means that you gave your money to someone. So never ever give up your private key to anyone else. So there are different types of wallets, but this presentation is not about the wallets. So therefore, we're moving on. So the cryptography and what role it plays in the blockchain DevOps and blockchain infrastructure and in the cryptocurrency. So cryptography, you're probably familiar with that. I just have an example here. I took word crypto. I applied in a top row the cryptographic algorithm calls inversion, and I get the result, the cryptographic hash in there. So you can see that it's very easy, but in Bitcoin, for example, a cryptographic algorithm called a simple hashing algorithm 256, and it's actually turning the word crypto into seemingly random string of letters and numbers. And they always, like, no matter what phrase or what amount of data you turn, you always get a hash that is very unique. So, and in order to reverse engineer, that's what hackers do, and that's how this technology is very secure. So in order to reverse engineer, it gets this 5.03 and so on and so forth, this number of seconds in a power 66 to convert it back. So to reverse engineer, to hack into it, to see what actually hash contains, it takes that much seconds to convert it back. But you ask me, what is this number of seconds? It's below the number 4.3 in exponential power 17. It's the number of seconds since the beginning of our universe. So hacker that would like to break the algorithm, secure hashing algorithm, has to live longer than our universe to reverse it back, to reverse engineer. And therefore, this is just one level of protection. Of course, in Bitcoin and Ethereum, in everywhere, because there are other layers, and we're going to be talking about it. But so far, nobody, it's not even, it's not even a job for the quantum computer, will not be able to hack that. Okay, so blockchain architecture. So what inside blockchain, we already know, a transaction ledger. So each record in a transaction is considered valid only when it's signed with a corresponding private key. So if I'm sending money to somebody's account, I need to sign this transaction with my private key. Otherwise, it is immediately deemed as invalid, the transaction. So therefore, this is one level of protection to get this signature into the private key. If I don't have my private key, I cannot sign the transaction. Therefore, it's invalid. So this is level number one. Second is something to do with the validators or the miners. And these are the people who actually entering the records into the database. We call them people just to kind of visualize them, but they are computer programs that belong to, that run on the computer, that belong to people. So this is there. So all it has to do with that, the ledger that we're talking about is not stored as one long list. It's actually every few minutes in Bitcoin, and every few seconds in Ethereum. It's these transactions are getting combined into the block, and this block is getting created, and it's kind of like sealed and secured, and no one ever can change it and access it. Well, can access reading, but not in the writing access. So no one ever can change the block. And this block is created and sealed by the miner or the validator. And it's all based on the premise that there are lots of miners in the network, and they all competing for the right to create a block. And what do they do to compete, to win? They actually have to solve the miner riddle, right? So in order to create a record, like to create this block, they need to solve the riddle. The riddle is actually simple. They need to apply secure hashing algorithm and create a hash, which is actually very easy until actually the blockchain difficulty rule comes into play. And that's how it is become the competition. Because blockchain difficulty rule, for example, right now states that hashing has to hash, so the hash result has to start with 18 zeros. So therefore, miner has a task to find a number just a number, which we call knots, that they can add to this block of transactions that's resulting hash and algorithm will start with 18 zeros. So therefore, what miners do, they simply add the numbers. Like, let's say they add number 0 into this hash and resulting hash, oh, have 3 zeros in front. You see 0, 0, 5. 3 zeros, we're getting closer. So let's try number 1. 6 zeros in front. We're making progress. So let's try 2. And that's what miners do, trying 2. Oops, no zeros. And so on and so forth. Miners are trying and trying and trying and trying different numbers. So all the miners in the whole network, they're trying different numbers to build this next block of transaction until voila, they find this number, or he finds, like whoever first finds this number is actually creates and seals the block, right? So after, n number of attempts, infinity number of attempts, I would say, even they create a block and they get a reward for it. So right now, a reward is 6.25 Bitcoin plus all the transaction fees that. So when you make a transaction, you also do the transaction fee. So this is what is they getting in the result, and that's the new cryptocurrency, and this is how they getting paid for supporting this infrastructure. Remember we say, so there's no single company that supports the infrastructure. It's the whole networks, it supports itself. And that's how people getting paid for supporting this network. Every time they create a new block, then they get a reward. A reward is quite substantial if you know how much is Bitcoin right now. So basically, it's called proof of work. So miners are proving that they made a work, that they put money into that block, and therefore they get rewarded. But only one miners out of many, many, many thousands of them all over the world. That's why miners are investing into this expensive equipment, millions and millions of dollars, in order to get their chances to get their computer power up and get bigger chance to win that competition. And this is the block itself is not only way to protect, but also the architecture of the blockchain. And that's how it calls the blockchain, because every subsequent block is actually bound to the previous block because it contains the hash of the previous block. Therefore, if you would like to change any hacker would like to change anything in any block, it needs to recalculate all the subsequent blocks as well. And we just went through how hard it is, and there is a competition about it. So therefore, blockchain security is unbreakable. And just about the crypto economy, it has the whole, that's how fascinated the system are. It's not that the one company is paying for the supporters, for DevOps, to support the infrastructure. It's the network self-sustain itself. So how does it do it? So I took a period of time when Bitcoin was going down and down and down and down in price, and everybody's saying that Bitcoin was dying. So kind of like the worst part. And I show you how it actually worked for the crypto economy. So when Bitcoin was going down, we have constantly the number of miners still going up until the price of the Bitcoin was not anymore financially feasible for them to sustain their business, and therefore they start dropping off if you see the decline in this graphic. So what the blockchain difficulty rule, the blockchain itself self-adjusting. So it all constantly monitoring the number of miners in the network, and when the number of miners started dropping, so as blockchain difficulty. Therefore, when the blockchain difficulty drop, it becomes easier to get this nonce number and solve the miner riddle, and therefore number of miners start climbing again. So you can see here it start climbing again. So once the blockchain difficulty decreases, and therefore it self-regulates. And as I said, the usage transactions per day, even though the price of Bitcoin is going down and down and down, and everybody's saying it's dying, you see that number of transactions is going constantly up. All right, so and level number 4, how this infrastructure protect itself is the transaction fees, and this is the spammer protection. So yes, so sometimes when I hear people say, oh, we created our own blockchain and it doesn't have the transaction fees, this is the worrying sign, because transaction fees are protection from the spammer. Naturally, if spammer has to pay for every transaction, and less likely to spam the network. So therefore, transaction fees are there for the reason as well. So every time when you transfer money, transaction fees are getting applied. So what to build on the blockchain? Actually, tons. And right now, let's just look where you can build. So Bitcoin. Bitcoin was created in 2009, and it was created as peer-to-peer electronic cash system, and it exists. So right now it's about 400,000 transactions. Well, right now it's even more than that. And you can think of the Bitcoin as a bank. So it's using for the money transfers and transactions and the payments. But there is also another network that is probably right now the most popular between all the blockchains for the creation. This is Ethereum. So it's smart contract and a decentralized application platform. So you can build your own app on the Ethereum. So it also can act as a bank. You can do the payment system via Ethereum, but what is more than that and more useful than that, you can build not one bank, but you can actually build millions of banks on Ethereum if you wanted to, of course. And it's also decentralized. It's also protected by cryptography, coins released by mining, and it has way more transactions per day than Bitcoin, for example. There are other competitors to Ethereum, which is emerging out, and you can look them up: Polkadot, Cardano, Casper. There are many, Solana that coming out as well. So you can see others that are doing the same as Ethereum, but Ethereum still have the largest network and right now is unbeatable. So what is the good in Ethereum? You can build apps, you can build platforms, you can build also new currencies in there. As I said, like new banks, right? So you can build new financial systems and you can build new currencies. And to build a new currency on Ethereum, it takes literally just 5 minutes. So all this created on Ethereum currencies you see right now, so they are very, very popular. You can, you probably Tether, USDC coin, Avi, DAI. So they all of them built on top of Ethereum. So, and what is making cryptocurrencies decentralized versus centralized? Of course, you've heard about, Libra, digital yuan, digital dollar. So they, all the governments and companies, they trying to build their own cryptocurrencies, but they may be cryptocurrencies, but they're not decentralized. So they're not point in kind of, I don't see any use in them other than, banks already have digital dollars we use all the time now via credit cards. So we don't pay cash, we pay credit card, we pay digital, it doesn't matter. But what is the power of the cryptocurrency is actually in decentralization that is not controlled by any government, it's not controlled by any company. Yeah, so about blockchain business ideas, you can build tons and tons and tons on the blockchain. I'm not going to go through that in detail. Maybe we will have another talk about it. Yes, I have registry, tracking, voting, games, wallets, metaverses, marketplaces, financial application, decentralized finance right now is very, very big. So if you right now hearing people making money, and that's where they're making money on decentralized finance, basically on the lending, on the borrowing, on prediction markets. So all that, so you can look it up and you can build it yourself as well. It's not that hard. So how to build? So here I found actually my old picture when I was creating it on the bloggeeks.com. So you can look up my article and it's actually have step-by-step instructions on how to do it. But basically you can see the architecture of, let's say if we take the ASP.NET application architecture, when we have just the web browser, web server, and database. So same web browser you can apply, but you talking to the smart contract that deployed in one of the nodes. Smart contract by deployed by the address, and you basically from the web browser, there are APIs that you can address just right to the smart contract in the database, and voila. So this is how your decentralized application works. Yes, if you would like to build your first app on the blockchain, again, go to Crypto Academy. All instructions are there. So, but when we're building on Ethereum, there are lots of good things, right? So you can build apps, you can build new currencies, also smart contracts written in this JavaScript like language Solidity. So if you know JavaScript, so there's minimum transition into blockchain programming. And therefore you can have unlimited opportunities because this area is booming right now with the jobs, with opportunities. But there are problems as well. Transaction fees. The network got so busy right now. So in the busy times, you can pay for one transaction up to $200. Blockchain people are paying that because it's still worth it. The transactions are going through there. It's like in millions of dollars. So therefore, $200 is not even kind of like that big amount of money. Also low transaction throughput, which is like, let's say, like if we're comparing it to the Visa or the bank transactions, it's slower. Smart contract programming is still very different because you need to kind of design for the decentralized world. It's different. So there is a learning curve there. And also the data storage is extremely, even I said it's database, everyone store the metadata data there because you cannot afford right now to store actual data. If for one image, it will cost you more than $1 million to store. So basically that's the difficulty, but we have a solution, and that's what Metis does. And there are also other layer 2 solutions, but we're building a layer 2 roll-up platform. So while locating on still on Ethereum, so it provide low gas fees, fast transaction, native storage as well, and simple implementation. So we're solving the problems that I just stated. So what we do and how we do it, we do it via the technology layer 2 optimistic rollup when we bundle all the transactions, like millions of transactions in one, and then committing them at once into Ethereum. So therefore, the gas fee is split between the transactions. So there are also other improvements, but a lot of also builder benefits in there. So therefore the projects, for example, they get profit from every transaction while running on Metis. Project also can create their own token and can attract investors right on Metis. Built-in IPFS storage, which allow you to still use the built-in storage without building your own, or without storing just metadata and building your own. No-code smart contract tool, this is right now what we're working on, and this is one of the builder benefits as well. This is what we do, and in our further lectures, we're going to be uncovering that and how we do that. So yeah, and we going live already in September. You listening this November already, so we are live. So therefore, go to metis.io and basically you can apply for the grant. So if you're building something and you have your own blockchain project that would run on Ethereum, it can run on Metis as well. And we are given the grants. So our grants start from $10,000. And then we also, our participants of the ecosystem, they get up to 1 million in the transactions. So like every time you make a transaction on top of the platform, you get the profit, additional profit, plus the easiness of build, tokenization, and storage. And also we have a hackathon that's probably already ended by the end, by the time you hear in the speech, but we will have more of those, and we usually have a very large prize funds as well. And we are hiring too. So DevOps, right now we have positions open with DevOps. You can go to contact@metis.io, check in this email and let us know if you're DevOps with a Solidity knowledge. Solidity is the programming language on Ethereum, and we are welcoming DevOps with this knowledge. And of course, subscribe, stay tuned. And this is my personal email right down there. You can, email me directly if you have any questions. I will respond. And I think that's it. That's all I have. Thank you so much for listening. Today we went over the blockchain. Today we covered a lot for the DevOps, a lot of the blockchain stuff, infrastructure stuff of the DevOps. My name is Elena Sinelnikova. I am CEO and co-founder of Metis.io, and it was a pleasure speaking to you today. Thank you.